If you've ever owned an EV, you know the fear. You're 40 miles from home, it's the middle of winter, your range estimate is dropping faster than the temperature outside, and the nearest fast charger has a line out into the parking lot. That's not a hypothetical, that's Tuesday for millions of EV owners right now. Tesla's answer has always been the same: bigger batteries, more superchargers, more infrastructure. BYD's answer is scale. Build so many EVs so cheaply that the rest of the world has no choice but to catch up. But what if the real answer isn't a bigger battery at all? What if it's an engine Mazda buried 12 years ago and just brought back from the dead to solve the one problem no EV maker has actually fixed? Stick around, because by the end of this video, you'll understand why an engine most people wrote off as a relic might end up being the thing that keeps gas stations relevant in an electric world. And this isn't a concept sketch or a car show teaser. This engine is already sitting inside a production car you can walk into a dealership and order today. That's what makes this different from the usual future of mobility promises automakers love to make. The big battery trap. Here's the uncomfortable math behind pure electric vehicles. Every extra mile of range means a bigger battery. A bigger battery means more weight, more raw materials, more cost, and, ironically, more energy just spent hauling the battery itself around. At a certain point, you're not building a more efficient car, you're building a heavier one that happens to also carry more energy. And that's before you even get to the infrastructure problem. Charging networks in North America and Europe have grown, but they've grown unevenly. Step outside a major metro area and DC fast chargers get sparse fast. Live in an apartment without a dedicated garage? Now you're relying entirely on public charging for a car that's supposed to save you time and money. The EV promise works beautifully in a handful of ideal conditions. Outside of those conditions, it starts to strain. This is the part of the EV conversation that doesn't get nearly enough attention. The industry loves to talk about range numbers on a spec sheet, but real-world range and advertised range are two very different things. Cold weather alone can knock a meaningful chunk off a battery's usable capacity, since the car has to spend energy just keeping the pack at a safe operating temperature. Highway driving at sustained speed eats into range faster than city stop-and-go. None of this is a flaw exactly, it's just physics, but it's the kind of physics that turns a 300-mile EV into something closer to 220 miles on a genuinely cold day, right when you need that range the most. Mazda looked at that gap, and instead of trying to out-battery Tesla or outscale BYD, went back to an engine almost everyone else had given up on. Mazda's crazy 12-year gamble. To understand why this move is so strange, you need the history. In 1967, Mazda released the Cosmos Sport, the car that put the Rotary, the Wankel engine, on the map. It was smooth, it revved like nothing else, and for a while it looked like the future of the automobile. Then reality caught up. Rotary engines burned through fuel, chewed through their apex seals, ran hot, and struggled to meet tightening emissions rules. By 2012, Mazda pulled the plug on the RX-8, and with it, the Rotary engine's production run ended. So why bring it back now in the middle of an EV revolution? Because Mazda didn't bring back the old Rotary, they brought back the concept and completely changed its job. For decades, the Rotary was defined by what it could do when it was pushed hard, spin to absurd RPMs, deliver silky smooth power, and do it all from an engine small enough to fit in one hand relative to a comparable piston unit. Those same qualities that made it a cult favorite in sports cars are exactly what made it a liability as a daily driver. Asking a Rotary to constantly shift through varying loads and RPMs, accelerating from a stoplight, cruising on the highway, climbing a hill, is asking it to do the one thing it's never been naturally good at. Mazda's engineers eventually landed on a simple realization: what if the Rotary never had to do that job again? The melon-sized electric engine. Here's the pivot that makes this whole strategy make sense. In Mazda's new range extender system, the rotary engine never touches the wheels, not directly, not through a transmission, not at all. The electric motor handles 100% of the driving. Instant torque, smooth power delivery, the exact feel you expect from an EV. The rotary engine's only job is to spin quietly in the background as a generator, topping up the battery. Because it's not tied to the demands of acceleration, braking, and highway speeds, that little rotary can just sit in its most efficient RPM range and stay there. No straining, no revving to redline, no wasted fuel chasing performance it doesn't need to deliver. It just makes electricity as efficiently as possible and lets the motor do the actual driving. And because rotary engines are so physically compact, Mazda's current production unit is roughly the size of a large melon. The packaging advantage is enormous. A single rotor engine takes up a fraction of the space a comparable four-cylinder would need, which means less added weight, better balance, and more room left over for the cabin and the battery itself. You get a car that drives like an EV, weighs closer to an EV, but never leaves you stranded looking for a charger. There's also a quieter benefit here that's easy to overlook. Because the rotary never has to respond to sudden throttle inputs, it doesn't need a transmission or gearbox at all. It just spins at a steady rate and generates electricity, full stop. That's fewer moving parts, less mechanical complexity, and less weight added back into a vehicle that's already trying to stay light. Every piece of this design points in the same direction. Keep the driving experience purely electric and let the combustion side of the equation do the smallest, simplest job possible. Fixing the unfixable apex seal. None of this works if the rotary's old problems come along for the ride, so Mazda spent years re-engineering the parts that used to fail. First, fuel delivery. The new rotary generator uses direct fuel injection, something rotary engines never had in their original production runs, which sprays fuel precisely into the combustion chamber instead of relying on older, wasteful methods. Less unburned fuel, lower emissions, better thermal efficiency. Second, heat management. Rotary engines have always run hot, and heat is what destroys them over time. Mazda redesigned the internal cooling channels and airflow paths specifically to pull that heat away faster, reducing the thermal stress that used to wear components down during long stretches of generator operation. Third, and maybe most importantly, the apex seals. If you've ever talked to anyone who owned an RX-7 or RX-8, apex seal failure is basically a running joke, and a very expensive one. Mazda rebuilt these seals using modern composite materials and reinforced surface coatings on the high-friction contact points specifically to extend how long they last under repeated sustained use. This is the part of the rotary that killed it the first time around, and it's the part Mazda clearly spent the most effort fixing. Put together, you get a rotary engine that keeps everything people loved about it, the compact size, the smoothness, without the reliability reputation that ended its production run in the first place. It's worth pausing on just how different the demands are this time around. The old rotary engines had to survive being redlined on a racetrack, driven hard by enthusiasts who bought them specifically for that kind of abuse. This new rotary generator has a much narrower, much gentler job. Hold a steady RPM, generate electricity, and repeat that cycle for years without drama. Engineering a component to survive one specific predictable operating condition is a fundamentally easier problem than engineering it to survive constant, unpredictable stress. That difference alone might matter more for long-term reliability than any single material upgrade Mazda made. Exposing Tesla and BYD's weakness. So why does any of this matter to Tesla or BYD? Tesla's entire model depends on two things: proprietary charging infrastructure and big battery packs. It's a strategy that works extremely well in places where that infrastructure exists. BYD's strength is different: vertically integrated manufacturing and cheap LFP batteries that let them undercut nearly everyone on price at scale. Mazda isn't trying to beat either company at their own game. They're targeting the exact spot both strategies leave exposed: drivers who want genuine electric driving feel every single day without depending on a charger being available, working, or nearby. No home charger required. No range anxiety on a long trip. No dependency on a growing but still incomplete network. That gap isn't small. Think about regions with weaker grid infrastructure, colder climates that hammer battery range in winter, or dense cities full of apartment dwellers who simply don't have anywhere to plug in overnight. In every one of those situations, a pure EV asks a lot of its owner. A car that drives electric but refuels at any gas station in 5 minutes asks a lot less. That's not a niche. That's a massive, underserved slice of the market, and it's exactly where Mazda is aiming. It's also worth noting what Mazda isn't trying to do here. They're not claiming this replaces pure EVs, and they're not pretending combustion is coming back in its old form. What they're offering is a bridge, a way to give hesitant buyers genuine electric driving today without asking them to bet their daily routine on infrastructure that isn't fully built out yet. For a buyer sitting on the fence, unsure whether their city, their climate, or their apartment building can actually support a pure EV, that bridge might be the difference between switching to electric now or waiting another 5 years.
Beyond gasoline, the hydrogen secret. Here's where it gets even more interesting, because gasoline might not even be the end point. Mazda has spent years developing hydrogen-fueled rotary engines, and the reason comes down to basic engineering. In a rotary, the intake and combustion strokes happen in physically separate sections of the housing, rather than sharing the same space the way they do in a piston engine. That separation matters a lot when you're burning hydrogen, because hydrogen ignites so easily that pre-ignition, the fuel igniting before it should, is a constant risk in conventional engines. The rotary's design structurally reduces that risk, which is exactly why Mazda has kept coming back to hydrogen rotary experiments for decades, long before this current range extender program even existed. Line that up with the platform Mazda just built, and the long-term picture comes into focus. The same compact rotary generator architecture that runs on gasoline today could, down the road, run on hydrogen instead, without redesigning the car around it. Same chassis, same electric drivetrain, different fuel source feeding the generator. That's a genuinely flexible platform, and it's one almost no other automaker is positioned to offer. This is what separates Mazda's approach from a one-off engineering trick. Automakers experiment with hydrogen combustion all the time, but most of those projects live and die as concept cars because building an entirely new platform around an unproven fuel source is a massive financial risk. Mazda has sidestepped that risk by building the rotary generator platform first, proving it out on gasoline in a real production car, and leaving the door open to swap in hydrogen later if the fuel infrastructure ever catches up. It's a patient strategy in an industry that usually rewards whoever moves fastest, and that patience might turn out to be the smartest part of the whole plan. The future of EV infrastructure. What Mazda's really betting on here isn't nostalgia for a discontinued sports car engine. It's the idea that solving a real customer problem matters more than following whatever the rest of the industry happens to be doing. Everyone else is racing to build bigger batteries. Mazda looked at where that race breaks down and built something that doesn't have that weakness at all. Now here's what I actually want to know from you. Do you think a range-extended rotary like this is a smarter long-term bet than chasing bigger and bigger batteries? Or is Mazda just delaying the inevitable shift to pure EVs? Drop your take in the comments, because I've seen this debate get genuinely heated, and I want to hear where you land. If this kind of deep dive into what automakers are actually building, not just what they're announcing, is useful to you, subscribe. Because next up, I'm breaking down BYD's push into Japan's K-car market and why the company everyone expected to fail there might be about to flip the entire segment upside down. You won't want to miss that one.